when we compose functions with their inverses, you should work from the inside out. But what happens if you have something like this that isn't a unit circle fraction or a unit circle angle if they're giving you an angle? How do we deal with that? Okay, well, let's talk through the notation real quick. Remember, inverse cosine is saying, hey, I'm giving you the cosine fraction. You tell me the angle. You tell me the theta value. So we can replace all of this with our theta once we figure out what our theta is. And tangent of theta is saying, hey, I'm giving you this angle. Now you give me the tangent fraction. Another way for you to word this is say, what is tangent theta when cosine theta equals 5/13? We've answered this over and over and over again in this class so far. They're saying, give me the tangent fraction, I'm giving you the cosine fraction. We know how to do this. Let's use triangles, just like we've done before. We're going to draw a triangle, label the sides, use SOHCAHTOA to label the numbers on the sides, use the Pythagorean theorem to find the third side, and then we will set up our SOHCAHTOA fraction and reciprocal if we have to, and rationalize if you need to. So let's draw a triangle. You can orient it however you want to, and you can put theta wherever you want to. I, out of habit, just always put it in that bottom corner. So that means this is the adjacent side, and this is the opposite side since it's across from it, and this is my hypotenuse. Cosine is the fraction. So they are telling me that the adjacent side is 5 and the hypotenuse is 13. I need to find the opposite side using Pythagorean theorem. You should be able to do this by now. All right, and now our question says, find the value for tangent. What is the tangent fraction? SOHCAHTOA. The tangent fraction is the opposite side over the adjacent side. Rationalize if you need to, but in this case, we don't have square roots. So that's it. We're done. If you can do triangles and you can do Pythagorean theorem and you remember SOHCAHTOA, you're good to go. Let's do 2 more examples. This next one is pretty similar, except we're going to have to deal with some weird square roots. And the third example, we'll have to deal with negatives. So reminder, this is asking you find the secant fraction when the sine fraction is 1/9. All right, let's draw our triangle, label. The sine fraction is the SO fraction, so my opposite side is 1 and my hypotenuse is 9. You should be able to find your third side using Pythagorean theorem. Last step, now find your secant fraction. Secant is the reciprocal of the cosine fraction, the fraction. So I need to flip to get secant, so my hypotenuse over my adjacent. On your homework, your ALEX system, you can leave it like this, but for me, anytime you have classwork or a take-home, you need to rationalize your denominator. Simplify 9/20 if you can, but I can't. So here's my final answer. All right, what happens if we're given negative angles in here? If it's positive, you can just do it like this, nothing to worry about. If it's a negative arc sine or arc cosine or inverse sine or inverse cosine or inverse tangent, if it's negative there, you need to remember that negative inverse cosine is in quadrant 2, and negative inverse sine and inverse tangent are in quadrants 4. So just pay attention. If they give you a negative, draw it in the correct quadrant, either the second or the fourth, depending on what you're given. So in this one, same idea. They're asking for the tangent fraction, and they are giving me that the sine fraction is -3 square root 5 over 7. This is a negative fraction. Sine is negative in the fourth quadrant whenever we are doing inverses. So you need to draw your triangle in the fourth quadrant against the x-axis and label it accordingly. This is the so fraction, so my opposite side is -3 square root 5, and my hypotenuse is always positive. Don't assume the negative goes with the top. Remember, you can have a negative anywhere in your fraction, and it just indicates something on this fraction is negative. So pay attention to your sides to help you figure out where the positives and negatives go. This is the positive x direction from the origin, and this is the negative y direction because we're pointing down, and this is always positive. All right, let's find my third side. You should be able to do this. Reminder, I don't use negative signs when I'm finding this third side because a lot of people mess up when they square it. So you don't have to use your negatives either. And when you distribute, you square your 3 and you square your square root. So it's actually 45. All right, now I just have to set up my TOA fraction. TOA. So my opposite is -3 square root 5, and my adjacent is 2. Rationalize if there was a square root in the denominator, and there's not, so I'm done. So reminder, everything's the exact same except if you have a negative inverse sine, arc sine, inverse cosine, arc, cosine, inverse tangent, arc, tangent. Pay attention to which quadrant you should be in. All right, the last three examples I want to show you are what happens if you end up with letters. The rules don't change, even though it seems scary and seems like we have a lot more going on. It's not. You're just going to end up with letters as your final answer and equations in your final answer. But it's the same exact rules. I'm still trying to find the secant fraction, and they give me my tangent fraction is 3w, even though that's not really a fraction that we're used to doing. But you can still draw your triangle, label your sides. Oh, opposite. This is the TOA fraction. Remember, you can turn anything into a fraction by writing it over 1. So it looks weird, but my opposite side is 3w and my adjacent side is 1. Just like before, find your third side using Pythagorean theorem. Square the 3 and square the w. I can't combine like terms because one has a w and one's just a number, so I'm going to leave it like that, but I can square root it because you want to know what c is, not c squared. So c is this weird equation here. So you leave the whole equation, the whole square root. Don't try and simplify it. You can't simplify it. Even though 9 is a square rootable number, it's not just a 9, it's 1 plus 9 and all this extra stuff, so don't worry about that. All right, reminder that secant is the reciprocal of cosine. So for my secant fraction, you need to flip cosine, so h over a. And my hypotenuse is this crazy thing. My adjacent side's just a 1, so your final answer, you don't really write things over 1. If you do on your test, I will not count off. It's just weird to write it that way. So there we go. We're done. So everything's the exact same. It's just instead of having nice, pretty numbers, we're going to have weird equations. But it's the same steps, so just take it one step at a time and you've got this. I am going to show you 2 more examples, the exact same thing. It's just different letters and for us to work through. But if you feel comfortable, you're good to go. All right, find the exact value. I'm looking for the sine fraction, and they give me the cosine fraction is 4v. So we're going to draw our triangle, put theta wherever you want to, label the sides, and this is the cosine fraction. I can turn it into a fraction by writing it over 1, so my adjacent side and my hypotenuse. Find your third side using the Pythagorean theorem. Distribute your squared. You cannot combine these because one's just a number and one's a number with some letters, a v. So they're going to have to stay separated, but I can square root it still. And this is my answer. You do not simplify that because yes, 16 and v squared and 1 are all square rootable terms, but when they're mixed together and held together with this minus sign, you can't square root it. So that's all we're going to do. All right, now we need to find the sign fraction. All right, the sign fraction is the so fraction. So the opposite side over the hypotenuse is 1, so I don't have to really write over 1. And final example, look for the cosecant fraction, which is the reciprocal, remember, of sine. If I give you that, the cosine fraction is just a w. Find the third side using Pythagorean theorem. The cosecant fraction is the reciprocal of the so fraction, the sine fraction. So it's 1, the hypotenuse, over this square root. This is one case where you do not have to rationalize. I will not ask you to do that because that's more than we need to get into.